6:49 this morning, and welcome back to the morning show. We're joined by Matt Sellen, the wise guy, and you've got a little helper. It kind of looks like a mini Matt today.
Well, he's awesome because I've known Will for years, since he was probably 5 and maybe 4 even, and he's a scientist.
Right.
Very
well,
good scientist.
Is Will Gibbons.
That's right. He's Will Gibbons from Catlin, Illinois, and what we're doing for the next few weeks is having students and their teachers come in and present interesting science stuff that they're interested in. And Will's teacher, Mr. Muskin, at Next Generation School. I'm a little nervous too. And so you're 10 years old, so you would be in around 5th grade, although they don't quite have grades there. But I think that it's about, well, so what you're going to do is you're going to show us some neat stuff on nanotechnology today, and about wires that remember their shapes and stuff like that. So you want to just go right ahead and talk about this stuff?
Last time I was here, I talked about something that was very large, the planet Uranus. But this time I'm going to talk about something very small, nanotechnology. I learned about nanotechnology thanks to my science teacher, Mr. Muskin, who also works at the U of I. Nanotechnology is the manipulation of atoms and molecules.
You're doing
To understand nanotechnology, you need to understand how small a nanometer is. If I took this meter stick and chopped it into a billion pieces, each piece would be a nanometer. But since that's kind of hard to conceptualize, I have this other demo. If this rope were the size of a human hair, then this grain of salt would be the size of 1 nanometer.
That's a good comparison. So tell us what you're going to do here.
Okay. Nitinol is a shaped memory metal. It's a very cool nanotechnology product. It bends and flexes when it is cool, but when it warms up... Where did it go?
Oh, we lost it.
No, it's right there.
Uh-oh. Did it launch itself?
Right
Oh, there.
Got it.
So that's very cool. So it was munched up into a little spring, and he put it in here, and
now straight.
It's straightened out really fast. That is neat. Okay.
Okay.
So while he talks about it, we're going to assemble this
When
thing.
nitinol is cool, it looks stuff like this. It can be in tons of different forms. But when it is heated up, it goes into its austenite form, which is very straight and rigid, kind of like this. Because it is forced into its austenite form when heated, it can make a really cool airplane launcher.
So what we've done here, there's a rubber band, and it's being held back by the metal all twisted up, and now he's going to put the hairdryer on the wire,
And we're going to launch
and it's going to launch the airplane.
Yeah.
And notice that I'm pointing it at the nitinol and not the hair and not the plane.
Oh, good job. Why do you point it at the wire instead of the plane?
Because when the wire straightens out, it releases the rubber band shooting out the plane.
Very good.
Okay. Nitinol can be used in many different things besides cool airplane launchers. Like for glasses.
Oh, wow. So it bend, but they're not going to break them.
Yep. Medical tools, kind of like this stent here. And orthopedics to attach tendons and ligaments to bones.
Very exciting. Well, tell us, Will, when we come back in about a half hour, you're going to show us some other products.
Yeah.
What are those?
Some sunscreen, tennis balls,
All right.
paint. Yeah.
More fun with nanotechnology. We're here with Matt Sellen and Will Gibbons, who I think is going to really take over at the U of I for math in the future.
I'm going to be out of a job.
Yeah, exactly. It is 6:53. If you have any questions, though, for our Wise Guy, you can always email us or check out Matt's website at wiseguy.net. Let's, for now, check in with Jennifer Ketchmark, who's standing by with our weather on the 3s.